everyone. Today we're going to take a look at simplifying rational expressions. Now, a rational expression is one in which you can see fractions and variables. So let's start with our first example. We're going to take a look at 5x cubed over 10x. Okay? Now when I look at this, I'm looking for a way to simplify. So I want to take a look at the 5 over 10 separately from the x cubed over x. So I'm just going to rewrite this so I can see things a little bit more clearly. When I have x cubed, that's the same thing as x times x times x. So x cubed is x times itself 3 times. That's what the definition of an exponent is. So if I take a look at this, I can see that I have 3 x's on the top of this fraction and 1 x on the bottom. Now, when that happens and everything's being multiplied, I'm allowed to cancel one of these x's on top with the 1 on the bottom. So now on the top, I'm left with x squared. Now, what do you think is going to happen to that 5 and that 10? Well, let's see. I can rewrite 10 as 5 times 2. That means that this 5 in the numerator goes into the 10 in the denominator twice. So I can actually also cancel out those 5's. So I'm left with 1 on the top and a 2 on the bottom. You can leave your final answer as x squared over 2. You could also call that 1/2 x squared if you want to. Both of those answers are a correct simplification of what we started with. Let's take a look at another one. What about 35x over 49x plus 28? Now this one's a little bit different from the first one because of that plus sign in the bottom. I can't go ahead and start crossing things out until I do some factoring. The only time you're allowed to cancel is if you have all multiplication. Okay, so let's think about this one. Let's think about some common factors that I may have here. Well, if I'm thinking about 35, 49, and 28. It's always good to think about the numbers first. Now, I'm pretty sure that 7, the number 7, can divide into all 3 of those numbers. Would you agree that 35 is the same as 7 times 5? So I can do 7 times 5x in the top. Now, if I take a 7 out of that expression on the bottom, the parentheses are going to give me 7x plus 4. Do you see that? Because 7 times 7 is 49, and 7 times 4 is 28. You might have heard your math teacher last year calling that factoring out the greatest common factor. Now you can see that there's a 7 in the top and a 7 in the bottom, both of which I can cancel out. So I can get rid of this 7 and this 7 as well. And now my simplification is 5x over 7x plus 4. Okay, let's just take a look at one more example. That was example 2, and now we'll do example 3. 2x plus 10 over x squared plus 7x plus 10. Now, a lot of students think that they can cancel out those 10's. You cannot cancel out those 10's because of the addition in this problem. So just like example 2, we're going to start with some factoring. Now, I believe that in the numerator I can take a 2 out of 2x plus 10 and call that 2 times the quantity x plus 5. The greatest common factor of 2x and 10 is 2. Now, what about the bottom? You've had practice with factoring already in this chapter. Okay, so I'm just going to factor this quickly. The two values that multiply to 10 and add to 7, that's going to be x plus 5 times x plus 2. Now, if I factor too quickly for you, just ask your teacher or go back to that factoring video, okay? Now, when I look at this, there's something common in the numerator and the denominator now that I've got all these factors. This x plus 5 in my numerator can cancel with this x plus 5 in my denominator. So I'll cross those out, and then my final answer is going to be 2 over x plus 2. Okay, great job, everybody.